Hello students, I welcome you all in this video. In this video, we're going to talk about a question where we have to find out the current in different branches of a circuit. See, when you see this kind of question, the very first thing that comes in your mind is KVL, KCL law. It means you can use the loop law to form the equations and then you can solve that to get the answer. But there's one more alternative way to get the answer fast, and that is nodal method, right? So nodal method is basically based on a concept that potential is a reference quantity and we can assume the one point to be at zero potential in the circuit and all other points, if their batteries are there, so we can write down the potential according to that point only. Means with the help of the reference of zero potential, we will write down the potential of all other points in the circuit, which is possible, right? So let us see how we can do it. Let me take this point. A point is at zero potential, right? If you consider the A point to be at zero potential, this is going to be 10. Why 10 volt? Because you are coming out from the bigger pole of the battery and the potential get added, right? So the potential drop has to be 10 volt. So 10 minus 0 is 10. That is quite justified. And the bigger pole has to be at the higher potential. So that's fine. Now this point is going to be also 0 because connecting wires are not going to have any kind of potential drop. And again, we are coming out from the battery. So this is going to be 12 volt, right? Now this end is also 0 because again, we are going through the connecting wire. And when you are going up, this end is going to be at the potential 9 volt, right? But you cannot cross the resistor, means you cannot write down the potential across the resistor if you don't have current through that. And current is the thing that we are finding. So we are not able to write down the potential of point B, right? See, if you know the potential of point B, then you are done, right? Suppose this point B is having potential X, then what's the current through 5 ohm? That is either 9 minus X or X minus 9 by 5. Through 10 ohm, either X minus 12 or 12 minus X by 10. In 4 ohm, X minus 10 or 10 minus X by 4, depending upon the value of X, right? Now the main point here is that we have to get the value of X. Now how to get the value of X? Let me just tell you a shortcut method to get it. Whenever we are interested to find out the value of X, we have to assume that X is at the highest potential. Don't worry, if the X is not the highest potential point, whatever value you will calculate, that you will get in your calculation, right? So but we have to assume here that X is at the highest potential. Highest potential means current will flow from that point to all possible directions, and we will use the junction law, and we will say that okay, there is no storage of current on the junction, so net current at that junction B is 0, and we will get the value of X. Okay, how? Let us see. If you assume that the X is at the highest potential, the current will flow like this. Consider this I1, consider downward current as I2, and consider here the current is I3, right? And since we have assumed the X is at the highest potential, so what I will write about the I1, see, actually if you talk about the junction B, then I1 plus I2 plus I3 has to be 0, right? And since the X is at the highest potential, so the I1 is going to be X minus 9 by 5. Potential drop by resistance is current. That plus here what? X minus 10 by 4 plus X minus 12 by 10. That has to be 0, right? Let us take the LCM of this. This is going to be 20. So this is 4x, 5 4 are 20, so 4x minus 36, right? Now again plus 4 5s are 20, so 5x minus what? 5 into 10 is 50 plus 10 2s are x, so 2x minus 24. That has to be 0, right? So now when you solve this equation, what we are going to get, this is 5 4 9x, 9 2 11x. So this is 11x minus of how much? This is 36 and 24, 60 and 50, 110. So it is minus 11x minus 110 is going to be 0 into 20, which is 0. So from here we can easily see this is 110 by 11, that is 10 volt. So X value we got is 10 volt. Now we are done. So with the help of this nodal method, you just have to solve one equation to solve the value of x, and then you can get the current in all the branches. If this is 10 volt, we can write down the I1 value, which is the current through 5 ohm, and that is going to be what? 10 is that, and 10 minus 9, which is 1 by 5. So that much ampere current is going from x2, means towards 10 volt to 9 volt, this way. The current here is going 1 by 5 ampere from right to left in 5 ohm resistor. If you talk about the current in 4 ohm, right? So current in 4 ohm will be what? That will be 10 minus 10, which is 0 by 4, that is 0. That means across 4 volt, across 4 ohm, potential drop is not there. The both the ends are at the same potential, so current will not flow through that. So this is 0 ampere, right? Now let's talk about the uh, third case, current in 10 ohm. Now current in 10 ohm is what? 12 ohm is 12 volt is this side, and this is 10, right? So this is 12 minus 10, which is 2 by 10, which is nothing but 1 by 5 ampere, right? And that is quite justified, because if the current is not going in the lower branch, whatever current is passing in 5 ohm, that current has to come from the 10 ohm only. So therefore we can see the currents are same, right? So this is how we can solve this kind of question very easily with the help of nodal method. And this method is very helpful for you if you are preparing for NEET or JEE. And this method is basically give you an idea that how to solve the question quickly. Time is going to be an important factor for your NEET and JEE exam, and this is a tool to minimize the time taking to solve this kind of question, right? Thank you.